Hi friends, in this video we are going to talk about the Poisson's distribution of vehicle arrivals. Now first of all understand in traffic engineering, the arrival of vehicles is assumed to follow the Poisson's distribution. We know there are lots of distributions, right? Binomial distribution, Poisson's distribution, chi-square distribution, normal distributions, like that too many distributions are there. In that, the vehicle arrivals is assumed to follow Poisson's distribution. So this itself can be a one mark question in the competitive exams. Now, before going into Poisson distribution in detail, let's imagine that, say, suppose you are standing here and you are taking the vehicle count. Okay, you're standing here and taking the vehicle count. Along with that, you are measuring how much time each vehicle is taking to reach at this location. Suppose this the first vehicle has taken around 5 seconds, let's say. Okay, 5 seconds. Now, after some time, the second vehicle is also reaching here at your location. Okay, so let it be the second vehicle is taking around 12 seconds, for example. Okay, and again, the third vehicle will be reaching here again after some time. Let's say that is the third vehicle is reaching after some 20 seconds. Let it be. One more I'm telling. The fourth one, okay, back-to-back vehicles may be coming now. The fourth one may be reaching here. The fourth vehicle. The fourth vehicle may be reaching, I'm telling, after some 30 seconds. Okay. Now let's see. The first vehicle has reached in 5 seconds. The second vehicle, what is the gap difference, the time gap difference between this first and second one? It is 7 seconds, right? 7 seconds. Now, what about the second and third one? That is 8 seconds, right? Now, the third and fourth one, that is 10 seconds, right? So, these are the times which are the difference between the successive vehicle arrivals, right or not? I can call these times as the time headway. So what is the meaning of time headway? This is the time gap between successive vehicle arrivals. Like that I can say. Right, the time gap between the successive vehicle arrivals. Now these are the times that we are considering in this Poisson's distribution of vehicle arrivals. Which means I'm asking you, what is the probability that? What is the probability that, let's say, some n number of vehicles are arriving in n number of vehicles are arriving in some particular t seconds. Okay, this n can be anything, this t can be anything. For example, what is the probability that some two vehicles are arriving in 10 seconds? Like that I can ask, or some 5 seconds, like that. So there is a direct equation to calculate that probability, which is given by Poisson. That's why we are calling it as Poisson's distribution. Okay, that is nothing but e raised to minus lambda t into this power lambda t raised to n whole divided by n factorial. So this equation you need to by heart. That is very, very important. Okay, e raised to minus lambda t into lambda t raised to n divided by n factorial. Now you know how to calculate this factorial and all, right? See, for example, okay, let me tell you what is this lambda first of all. This lambda is nothing but the vehicle arrival rate. Vehicle arrival rate, which means what? How many number of vehicles are coming in some particular time. For example, if they are telling that in 1 hour counting, we have seen around 360 vehicles, for example. In 1 hour count, example, we have seen or we have counted 360 vehicles. Means what? How much will be lambda then? 360 vehicles in 1 hour. 1 hour means how many seconds? 3600 seconds, right? So 360 vehicles in 3600 seconds means what? It will be 0.1 vehicles per second. I can write an equation or a rate like this, no? 0.1 vehicles per second. See, there is no meaning of this 0.1. There is no point of telling that 0.1 vehicles, no? So what is the meaning of this? In 10 seconds, maybe one vehicle will come. You know, we can also write this as 1 vehicles in 10 seconds. All these are same, no? We can also represent this lambda in vehicles per minute. For example, lambda equal to 360 vehicles in 1 hour means 60 minutes. Right or not? Like this also we can write, which means what? It is 6 vehicles per minute. Understood or not? So lambda we can represent in any unit, either in vehicles per second or vehicles per minute, or also I can write what is given 360 vehicles per hour, right? So this is also lambda. Okay, so there is no particular unit for lambda. It can be in vehicles per hour, vehicles per minute, or vehicles per second. But generally we'll try to represent this in vehicles per second, because most of the time the probability will be asked in some seconds only. Okay, most of the time we used to calculate in seconds, but it can be minute or it can be hour. Okay, that you will understand when I'm discussing some questions. Okay, now let's see if they are asking that, see, suppose I'm taking this particular example. So we got lambda equal to 0.1 vehicles per second. Okay, suppose if the question is like this, what is the probability that some two vehicles are arriving? Okay, what is the probability that two vehicles are arriving in, let's say, 5 seconds? This is the question. Okay, and also they are giving in 1 hour, we have counted that 360 vehicles are coming. So this statement also will be there in the question. Okay, according to, in this question, I'm taking this as the example. Okay, lambda 0.1 means if I'm taking the same equation, how to calculate this? I'm just taking it here. Just a second. Yeah. What will be the values then? If I'm substituting, this is equal to e raised to minus lambda is 0.1, t is 5 seconds. Right, this is what I told you. When I'm writing lambda t, if I'm writing this t in seconds, this lambda should be in vehicles per second. Then only seconds will get cancelled. The lambda t we should be getting in some vehicle term. Okay, see, for example, if I'm asking you this question instead of 5 seconds, if I'm telling that, or if I'm asking the question like this, what is the probability that two vehicles are arriving in, let's say, 5 minutes? Okay, then t I'm going to substitute as 5 minutes. In that case, lambda you substitute in vehicles per minute. Okay, like 6 vehicles per minute. Then only this minute and minute will get cancelled. We will be getting some 30 like that. Okay, so always it should be written like that, and this time unit should be getting cancelled, and the lambda t unit you should be getting in terms of vehicles, some number. Okay, so in this question, the time is in seconds, 5 seconds. So I'm taking lambda in vehicles per second. So seconds will get cancelled. I'll be getting in vehicles, right? So minus 0.1 into 5. That's it. Into lambda t is how much? 0.1 into 5. That is lambda t. Again, don't put minus here. This minus I have kept because in the equation itself I am having a minus. Okay. That is raised to how many number of vehicles? 2 number of vehicles. That is nothing but n. Divided by n factorial, which is nothing but 2 factorial. Understood? So this n is nothing but the number of vehicles which are asking in the question, not the total number of vehicles counted and all. The total number of vehicles counted we are using only to calculate the lambda value. Understood? So this, once you are calculating, you are going to get the probability. Understood? So this value I am not writing here. I have already taken some other questions that we will be discussing. I hope you got the concept, right? How to calculate the probability. Now you see in this equation, what we have written, e raised to minus lambda t, right? So this is exponential raised to minus value. Okay, so because of this minus and this exponential, we also call this probability distribution, the Poisson distribution, as negative exponential distribution, right? It is exponential, but it is negative, right? So this Poisson distribution can also be called as, it's a synonym of Poisson distribution, nothing but negative exponential distribution. So sometimes if they are asking a 1 mark question that the vehicle arrival follows options, you will be searching for Poisson's distribution, but it may not be there. They may be giving negative exponential distribution, which is the synonym of Poisson's distribution. Okay, sometimes they can give also like exponential distribution. So that is wrong. This is not exponential. This is negative exponential distribution. Understood, guys? Now let me take an example so that you will be getting the concept more clearly. Now look at this question. They are told that an observer has counted 240 vehicles per 1 hour. So I'm going to get my lambda value here. It is 240 vehicles per hour. That's it. This is in the vehicles per hour unit. Suppose I want to get it in vehicles per minute unit. Then what to do? 240 by 60 vehicles per minute. I'm not calculating right now. Let it be there. Suppose if I want to calculate in vehicles per hour, sorry, vehicles per second, then 240 by 60 into 60. That is nothing but 3600, right? So 240 by 3600 vehicles per second. So in any way, I can represent this lambda. Okay, you only if the values are changing, the units are also changing. So all these are equivalent. Now, in which unit I am going to consider? That depends upon the time, the unit of the time they are giving in the question. They are asking that one vehicle is arriving, which means n is equal to 1, and the time is given in seconds, right? 30 seconds, which means in which unit I am going to take lambda? That will be in vehicles per second, right or not? So how much it will be? That lambda I am going to calculate 240 divided by 3600. It comes out to be somewhat around 0. Just a second. Let me calculate it. Okay, it's going to be 0.0666, like that it may be good, no? So there is a point of confusion whether I should take a 0.0666 or 667 or 0.67, like 0.067, like this. You know, if you are taking different decimals, then maybe your answer also may be getting affected, no? So it's always recommended. What is my recommendation is, instead of simply rounding off lambda, what you can do, so in the equation, we are not using lambda separately, no? We are always using lambda t together, right or not? What is the equation here? P of one vehicle is equal to e raised to minus lambda t into lambda t raised to n is 1, divided by 1 factorial. So we don't require lambda separately, we require lambda t. So what you can do? To get accurate value, this lambda is 240 by 3600. What you can do? Directly you can multiply with 30. So this is going to be now in vehicles only, na? Seconds will get cancelled, right? So once you are doing this, exactly you are going to get 2. Try it, right or not? So better do like this so that you are going to get the value more accurately. Now we can substitute it, e raised to minus 2 into 2 raised to 1 divided by 1 factor, sorry, divided by 1 factorial. That's going to be e raised to minus 2 into 2 divided by 1. That's it. Okay, 2 raised to 1 is 1 and 1 factorial is 1. So once you are doing this, you are going to get 0.27067, like that, no? So look at the question. They have asked us in percentage round off to 1 decimal. So this I can convert into percentage. It's 27.067 percentage. But in 1 decimal, they are asking the question, which means 27.0 you can substitute, or 27.1 you can substitute. You will be getting mark for both. No issue. Understood? So range they may be giving somewhat like this, some 26.9 to 27.2 or 1, something like that. They may be giving the range, but don't think about the bigger ranges. Try to make your calculations more accurate. That's why I told you, instead of writing the lambda value separately, better you always calculate lambda t together, so that's a more accurate answer you may be getting. Okay, so I hope you got the point. Now let me take another question. So what good number of questions we are going to discuss here, so that concepts will be more clear. Now look at this question. Again, they told that it follows Poisson distribution. Even if this statement is not there, then also we are assuming that it's Poisson distribution, right? No need to give that statement. They are giving it just to give you better clarity. That's all. Now the mean arrival rate is 2 vehicles per minute. What is the meaning of that? Arrival rate is 2 vehicles per minute. This is what is given in the question. Okay, we can represent this lambda in seconds also. How? 2 vehicles, 1 minute means 60 seconds. Like this also we can write. It's going to be 1 by 30, right? Vehicles per second. Like this also I can write. Let it be. Now, In which unit they have given the time? They are asking in 1 minute. See, then is there any point of converting into vehicles per second? Not required. Right, that's what I told you. What we require is lambda t. So lambda t will be how much? Time they have mentioned in 1 minute, right? So since it is a minute, what I can do? Lambda I can take in vehicles per minute into 1 minute. So minute and minute will get cancels. We are going to get 2 vehicles into 1 is nothing but 2. That's it. So lambda t we are getting 2. In the previous case also it was 2 now. That's it. Okay. So it can have, see, don't think that always we'll be getting a proper integer. May not be like that. Sometimes you'll be getting some integer like decimal points also here. Try to take more accurate value always. That's it. Okay. Now what is the equation now? 2 vehicles. What is the probability that at least 2 vehicles, right? It's not 2 vehicles. It is at least 2 vehicles. What is the meaning of at least 2 vehicles, by the way? Probability of at least 2 vehicles. You might have already heard about such kind of usages, no, in probability. At least 2 vehicles means what? N can be 2, N can be 3, N can be 4, N can be 5, like that. Which means N should not be 0 and N should not be 1, right? It should not be the case of 1 vehicle arrival. It should not be the case of no vehicles are arriving. That also a probability, no? No vehicles are arriving in 1 minute. That also can happen. All the vehicles may be taking more than 1 minute, right or not? Like that. So what we can do? It's impossible to substitute n equal to 2, 3, 4, 5 like that and add all the things. So what we can do? Probability of at least 2 vehicles means what? From the total probability is always 100%, no? Or I can say 1. So from the total probability, what you can do? You can minus probability of n equal to 0. Also, you can minus probability of n equal to 1. Understood? So this is the case of 0 vehicle arrival and this is the case of probability of 1 vehicle arrival. So those 2 cases we need to minus from the total probability of 1. So we can add these 2 and together we can minus it from 1. So that we are going to get probability of at least 2 vehicles. So 2, 3, 4, 5, 6, 7, 8 like that. Understood, guys? So our task is to calculate how much is P of n equal to 0 and also how much is P of n equal to 1. This is the meaning of at least 2. Got it? Okay. Now, n is equal to 0 means what? E raised to minus lambda t. Let me write a general equation first. Lambda t raised to 0 by 0 factorial. So how much is lambda t raised to 0? That is 1. And 0 factorial, that is not 0. 0 factorial is also 1. So this equation will be e raised to lambda t into 1 divided by 1, which is nothing but e raised to minus lambda t. So I can just remove these portions, right? So this is equal to e raised to minus lambda t is how much? 2. E raised to minus 2. Let it be there. I will be writing the value later. Now this is equal to e raised to minus lambda t into lambda t raised to n is 1 divided by 1 factorial. Here you are going to get e raised to minus lambda t into lambda t divided by 1. That's it. I no need to write it. So this is e raised to minus 2 into 2, right? Lambda t is 2. So here I am getting e raised to minus 2. Here I am getting 2 times e raised to minus 2. Right or not? So in such calculations, you can simplify the calculations, right? So P of at least 2. P of at least 2. I can also write it as P of n is greater than or equal to 2. Like this also I can represent that. No? This is nothing but at least 2. Is equal to the total probability 1. From that I am minusing e raised to minus 2. Also I am minusing 2 times e raised to minus 2. So this within the bracket it becomes 3 times e raised to minus 2. No? So that's what I told you. Don't calculate it here itself and round off the value. Please wait till the last equation. You can easily simplify it, right? So much more accurate answer you are going to get. So once you are doing this, you are going to get 0.5939 something like that. Approximately 0.6 you are going to get, or I can say it is 59.39%, right? But in which unit they are asking? Are they asking us to represent in percentage? Now there is no word here, no percentage. Is it there? the probability round off to 2 decimal places. That's it. They didn't tell that in percentage. But in the first question, they were mentioning that it's in percentage. So if they are mentioning that it should be reported in percentage, then only you convert into percentage like we have done here, right? But in this second question, they didn't mention that it is in percentage. If they are not mentioning that it's in percentage, then don't convert it. Okay, so this step we don't require. They're telling round up to 2 decimal places, which means you can substitute 0.59. Maybe the answer key, they may be giving like this, like 0.58 to 0.62, something like that. Somewhat an answer key range they may be giving. But I told you, don't think about the range. Make your calculations more accurate always and substitute like that. That's it. Got it, guys? Suppose in this question, maybe the question was like this, in percentage, round off to 2 decimal. If the question was like this, then how we are going to represent the final answer? We'll be substituting like this, 59 point, then 2 decimal. So in percentage we are writing, but with the 2 decimals. Decimal means after point, how many places we need to keep. Okay, decimal places. Understood? So properly read the question. Here they didn't mention percentage. So the answer will be 0.59. Okay. Suppose if the question, here we have written at least 2 vehicles. No. Suppose if they are asking what is the probability that at most 2 vehicles are coming. At most 2 vehicles. What is the meaning of at most 2 vehicles? It can be 2. Can it be 3? No, it cannot be 3. It cannot be 4. It cannot be 5. Maximum to maximum. This is the meaning of at most. No, maximum to maximum 2 vehicles. Means what? It can be 1 vehicle also, or it can be 0 vehicle also. Means no vehicles are coming. Then also it is maximum 2. Na? Okay. So if they are asking what is the probability that at most 2 vehicles are coming, then what we need to do? We need to calculate P of n equal to 0. We need to calculate P of n equal to 1. We need to calculate P of n equal to 2. And all these things we need to add. We need to take the sum of all these three. That is nothing but probability of at most 2 vehicles. So remember these two usages, at least and at most. Okay, or they can ask exactly one particular. So here we have discussed that in the first question what it was, exactly 1 vehicle. This was not at most 1. This was not at least 1, right? Exactly 1 it is. Okay, that's why we have substituted or we have calculated only one particular value. Hope you are getting the concept, right? Now look at this, another way of asking the question. Here also they have given that the arrival rate is 180 vehicles. 180 vehicles in how many? How much time? 30 minutes. Okay, let it be there. So it is 180 vehicles in 30 minutes. So if I want to simplify it, it's going to be 6 vehicles per minute, right? I can also write it in seconds, which means lambda equal to 180 vehicles per 30 minute means it's going to be 30 into each minute is 60 seconds, right? So this is going to be how much? 0.1 vehicles per seconds. Like this also I can write. Okay, no need to write in all the units. Let's see in which unit they have asked the time or they have mentioned the time. It's in seconds, no, seconds. So which means we need to substitute the lambda value in this format. Okay, so the first stage, as I told you, we can directly calculate lambda t. How much is lambda t then? It's going to be 0.1 vehicles per second into time is 6 seconds. Seconds will get cancelled. We are going to get 0.6 vehicles. So let it be 0.6. Okay. Now they are asking what? The vehicle arrival follows negative exponential distribution. Okay. Now the probability that no vehicles are coming. What is the meaning of no vehicles are arriving? N is equal to, very good, 0. That's it. No vehicles means n equal to 0. Okay. So let's calculate it. P of n equal to 0 means e raised to minus 0.6 into lambda t again. 0.6 raised to 0 by 0 factor. How much it is? E raised to minus 0.6. Right. 0.6 raised to 0 is 1. See, don't put it as 0.6 and all. Okay. This is the mistake I have seen from many students. Okay. Because they may be writing the exam in, huge tension. and by mistake they will be putting like this. Okay, don't don't lose your valuable mark. Okay, it's actually 1. So anything raised to 0 is 1. By 0 factorial is also 1. So just calculate. You're going to get this value as 0.5488. Right or not? 0.5488. So now in which unit they are asking? They simply told that round off to 1 decimal place. Did they mention that it's in percentage? No, they didn't mention. So since they have not mentioned, no need to convert into percentage. So round off to 1 decimal place. So we can put it as 0.5. That's it. We can substitute like this. Maybe they'll give the answer key like 0.4 to 0.6 like that. Or sometimes they will be giving like this only 0.5 to 0.5. That's it. Like that also they can give the range because only simple calculation. No, it is. Okay. No need to keep it. See, no one is going to keep 0.4 unless and until they are making mistake. There is no point of keeping it as 0.6 also, or maybe like 0.4, 0.62. I mean 0.5 to 0.6. Maybe they can give, but there is no point of giving 0.6 because this is nowhere related to 0.6. Right? If it was like 0.57 something like that or 5.6, then maybe they will giving 0.5 to 0.6 like that. Okay, so more accurate value you can substitute always. Got it, guys? Now, if I'm going back to this question, see what is the meaning that no vehicles are arriving in 6 seconds gap. What is the meaning of that? If I'm going to the first example, here, is there any vehicles which are coming in 6 seconds gap? If I'm taking only these 4 vehicles example, is there any vehicles that is coming in 6 seconds? Yes, there is a vehicle which is coming in 6 seconds. No. Okay. If I'm asking you, what is the probability that 0 vehicles are coming in, let's say 4 seconds. Is there any vehicles which are coming in 4 seconds here? Is there any vehicles? No. All the vehicles are taking more than 4 seconds gap. Right? All the vehicles are having a time headway of more than 4 seconds. So this is the situation. So 0 vehicles in some particular time means all these time headways are greater than all these time headways. Generally, we represent using the symbol HT. Time headway suffix time headway is less than t seconds. That's why the number is 0. Right or not? Okay, so if they're asking that, what is the probability that 0 vehicles are coming in, let's say some 3 seconds? What is the meaning of that? If 0 vehicles are coming in 3 seconds, what is the meaning of that? All the time headway is greater than 3 seconds or greater than or equal to 3 seconds. Like that also we can say within 3 seconds whether they have reached or not. No, the first vehicle has taken 5 seconds. Within 5 seconds, it has not reached. It has taken 5 seconds, or all the vehicles have taken 5 seconds or more. Right or not? So in the same question, let's say, 1 second. Yeah. The same question, instead of telling that no vehicles are arriving in 6 seconds, they can also use they can also give a usage like what is the probability that the time headway HT is greater than or equal to 6 seconds. Like this also they can mention. Then also the question is same or not? Yes. The time headway or the time taken or the time gap between each vehicle is greater than 6 seconds. That is the reason why they have not reached within 6 seconds. Okay, they have taken or they will be having a time headway of 7, 8, 9, 10 like that. Understood or not? So the question can be like this also. Same question or same answer it will be. Read the question. What is the probability that the time headway of vehicles is greater than or equal to 6 seconds? What is the meaning of this, guys? The meaning is that the time headway is greater than or equal to 6 seconds. Means what? N will be 0 in or within. N will be 0 within 6 seconds. Right or not? Okay, so this usage also you need to remember. What is the meaning of this? Probability that time headway less than t means probability of n equal to 0. Sorry, not less than t. greater than t. Okay, or greater than or equal to t. Okay, so probability of time headway greater than or equal to t is equal to probability of n equal to 0. So this has already asked in the gate examination for 1 mark. Okay, so not in this format they have asked. P of n equal to 0 means what? E raised to minus lambda t into lambda t raised to 0 by 0 factorial, which is going to be equal to e raised to minus lambda t. So like this only they have asked. What is the probability that time headway greater than or equal to a time t? This was the question. And in the option, one of the option was e raised to minus lambda t. Other options they have kept something like this, e raised to, 1 minus e raised to minus lambda t or e raised to lambda t, something like that they have kept. So remember this negative symbol also. Okay, e raised to minus lambda t. So you look at this. They have given one option like this also. 1 minus e raised to minus lambda t. What it will be? See, total probability is 1, no? So this value, if I'm minusing from 1, what I'm going to get? I'll get probability of time headway less than t. You know, probability of time headway less than t will be 1 minus probability of time headway greater than or equal to t, right? Because total probability is 1, no? So I can write it as 1 minus e raised to minus lambda t. Okay, so these two equations you need to remember. So this first equation is already asked for 1 mark. Now this also can be asked. Remember this, okay? Greater than or equal to means n is equal to 0. Less than means 1 minus p of n equal to 0. We can write like this also, now. P of 1 minus p of n equal to 0. Got it, guys? So I hope this concept is very clear. Now, look at this question then. I've just taken a question like that also. What is the probability that the vehicles is less than t seconds? Then what to do? Probability of time headway less than 6 seconds. If they are asking questions like this, what you have to do? Directly you can take 1 minus e raised to minus lambda t. Right, you calculate it. See, already we have calculated the second part, no? This e raised to minus lambda t, we have already same data, no? Same data of previous question. Okay, so this is equal to 1 minus 0 point, how much it was? 5488, right? If I remember correctly, it was 0 point, let's say, just a second. Yes, this one, 0 0.5488, right? Don't round it off. This we have rounded to 5.5 because it was asked in 1 decimal. That's why. Okay. So take the accurate value always, 0.5488. So let's substitute that value here. Now this is going to be equal to 0. Approximately 0.45. Right or not? Approximately, if I'm taking this as 0.55, approximately 0.45. Round off to 1 decimal we require. So you can round it off to just 1 decimal. No? So 0.4 or 0.5. You can substitute. Both you will be getting the answer. Mostly they will be giving the answer key range like that. 0.4 to 0.5. That's it. Okay. So here also, as I told you, suppose if they are mentioning that it's in percentage, then only you convert it to percentage. Otherwise, don't do it. Okay, guys, that's it. Now another type of question. Okay, so if you are discussing this question as well, the entire concepts of Poisson distribution is completed. Okay, so look at this. What they are asking is, till now what we have seen is, they will be asking either the time headway is less than a particular time or greater than a particular time. Like that only we have seen, no? Either a probability of time headway less than t seconds or probability of time headway greater than or equal to t seconds. Right or not? Okay, so now what they are asking is, in between two particular times, what is the probability that it will be in between 6 seconds and 10 seconds? Right or not? So what to do? So if I'm just taking that HT can be, 1, 2 or 0. 0 also I can put letter B. 3, 4, like this, it can go. 6, 7, 8, like that. 10, 11, 12, like that. Any seconds it can be, na? Now what they are asking is, what is the time, what is the probability that it should be within the 6 and 10? Right or not? So either, see, it may not be always integer, no? It can be 6.1, 6.2, 7.1, like that. It can be anything. So this probability is what we need to calculate. How to calculate that? You can calculate what is the probability that it is greater than 6. First of all, greater than 6 means what? Just a second. Greater than 6 means what? It can be 6, it can be 6.1, it can be 6.2, it can be 7, 7, 8, 9, 10, it can be 11, it can be 12, right? It can be any value. It can be 13, 14, 20, anything. But they are not asking complete value greater than 6, no? They are asking between 6 and 10. Means what? If you are calculating what is the probability that time headway less than 6, you are getting this entire thing. We don't require entire thing. We require only till 10. Which means what? From this value, you can easily minus all these values which are greater than 10. Right or not? We don't require entire values now. From this, we can minus this second portion. Just a second. Just a second. So from here to whatever you are calculating, all those portions we can minus. Okay, this will be going into some infinite number. We don't know what is that. So what will be this portion? Probability that, let me just run this. Just a second. Yeah. So this portion will be probability that the time headway is greater than 10 seconds. Now see, our equation is greater than or equal to 10, or it can be less than or equal to some particular time. See, if it is coming like equal to, you can take any probability, doesn't matter. Okay, so P greater than or equal to 6 or greater than 6, both are having same equation. That's what I'm telling you. Or P HT greater than 10 or greater than or equal to 10, both we used to take same equation. Okay, there will be a slight difference in the value. There should be a difference, but that is not considered in this probability calculation. See, probability itself means what? It's like a probability. We are not 100% sure, right? It's like a prediction only, no? So some small variation will be coming if I'm putting greater, or if I'm not, I mean, simply greater or greater than or equal to. So that difference we are not considering in the Poisson distribution calculation. If you are getting confusion, what I mean is, see, suppose, where is the question? Yeah. So look at this question. Suppose in this question, they have given simply like this. What is the probability that the time headway is greater than 6 seconds? Suppose the question is like this. Equal to is not there. Then also this procedure will be same. That's what I'm telling. Same equation we are using for greater than or equal to. Okay, there is no difference. That's what I'm telling. Got it, guys? Right. Now coming back to this question, what we need to do now? Let's calculate what is the probability that time headway greater than or equal to 6 seconds. Then we'll be getting some value. How much it will be? For greater than or equal to, we are using the equation e raised to minus lambda t. Right. Greater than a particular seconds means e raised to minus lambda t. So here it's going to be e raised to minus lambda into 6 seconds. And from that, we need to minus time headway greater than or equal to 10 seconds. Okay, it's going to be e raised to minus lambda into 10. Okay, lambda t, which is nothing but lambda into 10. Now, why we have minus this greater than again? See, from this entire value, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, like that, we need to minus the values which are greater than 10. 10, 11, 12, 13, 14, all those things we need to minus. Then only this remaining portion, 6, 7, 8, 9, and all, we may be getting. Understood, guys? So calculate it and you can minus it. So once you are doing this, how much is lambda, by the way? 360 vehicles in 1 hour. Like per hour means 1 hour. So lambda means how much? 360 vehicles in 1 hour. That's going to be, so 1 hour means what? See, here all the times are given in seconds, no? So that seconds we can just convert into 360 vehicles per 3600 seconds. It's going to be 0.1 vehicles per second. So here I cannot calculate simply lambda t because there are 2 times here, no? So we need to calculate lambda separately. Got it? So e raised to minus 0.1 into 6 is nothing but e raised to minus 0.6 that you can calculate. You will be getting this as 0.5488. Similarly, this is going to be e raised to minus 0.1 into 10, e raised to minus 1, right? Nothing but 1 by e. That's it. E raised to minus 1. So that's going to be, we are having the calculator, so no issue. This is going to be 0.3679. So from this first one, you calculate the second one. So what is, how can we represent this question, by the way? Between 6 and 10 means, how can we represent it? We can represent like this. P of 6 less than or equal to HT less than or equal to 10. Something like this we can represent. I told you this equal to doesn't matter if you are putting this equal to or not putting this equal to, doesn't matter in probability. Okay, which means see, like this if you are putting or probability of 6 greater than or equal to HT less than 10, like this if you are putting, or P of 6 less than HT less than or equal to 10, like this if you are keeping, all these are considered to be same in this particular context. Practical point of view, this is different, right? Equal to means equal to, less than means not. We'll not consider that equal to, enough. So practical point of view, this is different. But in this Poisson distribution calculation, all these things are same. Right or not? So that's going to be equal to e raised to minus. We can directly write like this, no? If you are asking such a question, we can directly write like this. Now onwards, no need to get any confusion. If they are asking between two times, then you just take one of the time like this, other time like this. Since it is e raised to minus and all, you keep the bigger value as t1, sorry, smaller value as t1, bigger value as t2, because there is a minus here, no? That's why. Okay, so smaller value you keep as t1, then only this first term will be higher value. Okay, so that's going to be 0.5488 minus 0.3679. That's going to be approximately 0.18. Right? So they are asking in two decimals, so 0.18. Okay, so some range they may be giving, some 16 or some 17, whatever, 0.16 to 0.20, something like that. They may be giving the range. Got it, guys? So any question, if they are asking what is the probability that the time headways within some, see, let's say 8 seconds and 12 seconds, what you can do? You just calculate lambda and directly you can put e raised to minus lambda into 8 minus e raised to minus lambda into 12. Okay, so between any time like that, if they are asking, directly you can keep it like this next time onwards. Got it? That's it. These are the different types of questions which can be asked in the Poisson distribution concept. Okay, so I hope you got the concept, and I hope you also got the confidence to attend whatever question they are going to ask in the exam. Okay, so if you have liked the video, please give your feedback in the comment box and also share the video link with your friends. So thanks for watching. Bye.